All right, another fun-filled episode of Similar Triangles. Woo! The last lecture we talked about how to show using the angle-angle method, okay? How to show two triangles can be congruent, or similar, excuse me, and how to use it to set up proportions to solve missing sides, okay? Excuse me. Same concept, two different postulates. First one, side, side, side talks about using just the lengths of the sides, okay? And the SAS talks about using combination of sides and angle, okay? We have two additional resources, several pages on the notes I've provided for you, 12 to 17, some extra explanations and examples for you. It's a good one. You'll like a couple of the examples. They're cute. Okay? And then the PowerPoint. Okay? So, here we go. Here's examples and words. The side, side, side postulate says if the measures of the corresponding side lengths of two triangles are in proportion, then the triangles are similar. Here's what that means. Okay? Now, in this example, I have put them in order, so to speak. But you can't always think that way. Sometimes you're going to have to turn one of the triangles to match them up. And here's a train of thought I'd like you to think about to make it a little bit easier. Okay? Your Goldilocks, they're the three bears. Okay? Little to little. Okay? Then the medium side and the medium. Large with large. Okay? Baby bear, mama bear, papa bear. Match them according to their relationship. So, if I think that way, 4 over 8 simplifies to 1/2. 6 over 12 simplifies to 1/2. 9 over 18 simplifies to 1/2. These sides are in proportion because they all simplify to the same term. Remember, that's our scale factor as well. So, to put these in a similarity statement, matching sides and angles properly, okay? In this case, it's probably just as easy because I did put them in order. Okay? And if you're asked about the scale factor, you can show what it is. Now, side, angle, side. If you remember back to when we talked about congruent triangles, when they were identical, and we said the order of the letters is important, it still is. That angle has to be between the sides, or formed by the sides, that are in proportion. Okay? Now, our example. Okay? First off, we have congruent pair of angles. So there's good. There's the A. It says the measure of two side lengths of a triangle are proportional to the measure of the two side lengths of another triangle, and the included angles are congruent. So, here we go. Once again, make sure they coincide. 8 over 4 simplifies to 2 over 1. 18 over 9 simplifies to 2 over 1. And yes, the angle is between our sides in proportion. So, we set it up again. Once again, however you see it, just match them properly. K, D, J. R, P, Z. Okay? And there we have it. Okay, so those are the two we're going to deal with today and move forward. Okay? Come on over here. Okay, our first example, and once again we have that nasty glare, and that doesn't help anybody, does it? Okay, here we go. It says the same thing that the last one did. Determine if the triangles are similar If so, write a similarity statement, just like we just did. Triangle is similar to, okay? If they're not, what more information is needed? Okay, makes us think a little bit. So here we go. First one. This is what I told you about over there. Sometimes we have to turn. Put shorter side with shorter side, longer with longer. So, 18 and 24. 18 is the shorter, so we go over here. 12 is the shorter. Is 18 over 12. Okay, we simplify that to 3 over 2. Okay, now we match 24 and 16. 24 over 16, also 3 over 2. Yes, because we have a common or equal angle in between. We've got side angle side. So yes, they are similar. Okay, so however you want to set this, I'm going to do it this way. Watch this. JAK is similar to triangle WSY. Now, you may be asking why I did it that way. Here's why. Because that angle is the middle one, sometimes it's easier for me, just as I've done, to match it. Okay? Side, angle, side. Okay? Short side, angle, longer side. Short side, angle, longer side. It's just one way to do it. It's not the only way by any stretch of the imagination. Okay? It's just one way I look at it because it's easier for me to remember. Okay? And I'm old and I forget things. Okay? So, number 2. Well, we have some sides here, and look, that's our common angle right here. Okay? Do we have a side in between the angles? No. Okay, we have a side of a triangle, because remember, we have triangle PRQ and triangle PNM. 4 is the side of a triangle. 8 is the side of a triangle. 18 is the side of a triangle. 6 is not. We would have to look at 24 over here. So we would have the actual length of a triangle. Then we would kind of say, okay, 18 over 24 and 4 over 8. Those don't reduce to the same thing. 4 over 8 is 1 over 2. 18 over 24 is 3 over 4. They're not equal. We don't have a common angle to work with. Okay? We need more information. That's all you'd really have to put. Okay? Not enough information. Okay? Let's move over here. Now, we have 4 problems over here, which, just like the other day, oops, there we go. I think I got as much of it in there as I can. Identify the similar triangles. So we're being told that they're all similar. Okay? And find the measures. And put the measures that we have to find. So let us begin with the same concept we did before. Okay? Now, on this particular one, okay, this has to rotate over. So the 4 and the X go together. And the 6 and the 10 go together. Oops, that's 6X. Six goes into 40 6 times with a remainder of 4, which is 2/3. So, FG, 6 2/3. Yes, you can use decimals if you prefer. That's perfectly okay. Okay. Number 4. Okay? 8 and 6. Now you're probably thinking, well, wait, they both revolve around a right angle. But look, we also have our vertical angles. So, between the two equal angles, between the two equal angles. So those are going to go together. These are going to go together. Just like the other day, I like to simplify early. So 8 over 6 becomes 4 over 3. Okay? Okay, so x equals 15. Okay, 15 plus 1 is 16. 15 minus 3 is 12. Okay? Okay, here we go. Parallel lines, transversal. Here's our angle that's equal, in addition to that one, of course. Okay, now remember, we do need to have the entire side here. So x plus 4 plus x that's the entire side we have to use. So 14 over 20. Okay, 7 over 10. Once again, simplify early. X plus 4 is the small side. The longer of the sides. Okay. Okay, don't forget to distribute. So if x equals 3, BE, 3 plus 4 is 7. CE, just 3. Okay? Once again, as I've said before, the geometry is setting up this. Solution is algebra. And most of the math is pretty straightforward and simple. Okay? Just make sure you're following all your rules. Okay? Cross multiplying, we've got to multiply everything there. Distribute to everything. You're in good shape. Okay, our last one. We have our vertical angles. We also have parallel lines. So, to use the angle in between, we've got that equals that. So we do have side angle side here. Okay, so this goes with this. This goes with this. Okay, can't simplify here. Okay, so we work it through, we're going to get x equals 4. Okay. So, jk and jl. Well, 4 minus 1, 4 plus 1. Okay. There's that. Okay. We're going to move over here now for our last problem. Once again, like the last lecture, this one is a wordish problem. Okay? Okay. I'll bring, see, good. Okay? Just to make sure, put this properly. Okay. So, we've got a lighthouse that is casting a shadow of 128 feet. Okay? Nearby lamppost that's 5 feet 3 inches tall has an 8-foot shadow. Clearly we're dealing with a proportion. write a proportion that can be used to determine the height of the lighthouse and then find the lighthouse. Okay? That's light. Okay? This is a lighthouse. Okay? I didn't say it was a good lighthouse, I said it was a lighthouse. Okay? So it's got a 128-foot shadow. Okay? We have our lamp post. Also light coming out. Okay. Okay, so what I did here was take that 5 1/3. Okay, excuse me, 5 foot 3 inches. 3 inches over 12 inches is 1/4. So I turned that into a fraction right now. If you want to turn it into a decimal, 5.25. Okay? So we've got that 128. This has an 8-foot shadow. Okay? And this is our X. Okay? So, a couple of ways to set this up. I'm just going to do it this way. Height over height. Okay. And that's going to equal shadow over shadow. Since I went lighthouse, I stay with lighthouse. There's the A part right there. Okay. So, once again, I'm going to simplify before I solve. So, simplifies to 16 over 1. Okay. 5 times 16 is 80. 1/4 of 16 is 4. X is 84. There's our solution. Okay? We use the postulates to find lengths. Okay? We use the postulates to show that the triangles are indeed similar. If they are similar, then we can use the proportion to solve them. Because all we've got here is a triangle. Triangle. That's all it is. That's all this breaks down to. Okay? Very good. Talk to you soon.